Hi everyone, welcome back to my channel, GTR Math Tutorial. So for today's video, we will discuss definite integral. So the formula is integral of f of x from a to b equals uppercase f of b minus uppercase f of a, where the uppercase f is the indefinite integral. So f of x is the integrand. So f here is the indefinite integral. So all we have to do is substitute the upper limit and then minus the lower limit. Substitute to the f of x, uppercase. That means the indefinite integral of f of x. Okay, so try to answer 1 to 5. Screenshot first, try to answer before watching my solution. Okay, so let's start. Number 1. Okay, number 1. Number 1. So, integral of 3x squared minus 2x plus 1 dx from 1 to 2. So, first, let's just we have direct formula for each integral. So, this is equal to integral of 3x squared. So, just distribute the dx for every term. So, we have constant. So, we have 3 and then x squared dx from 1 to 2 and then minus. So, we have constant of 2. So, we have 2 integral of x dx from 1 to 2 and then plus integral of dx from 1 to 2. So we have direct formula for all integrands. So we just use the integral of u to the n du, and that is equal to u to the n plus 1 over n plus 1. No need to write the plus c because this is a definite integral. We have a lower and upper limit. Okay, so therefore this is equal to integral of x squared dx. So that is equal to, we have 3 here. So that is 3x cubed over 3 and then minus 2 integral of x. So again, in the form u to the n du. So just add 1 to the exponent. So we have x squared over 2 and then plus integral of dx. So that's simply x from 1 to 2. Okay. So let's just simplify. So we can cancel out 3 and then the 2. So therefore, we have integral of, x cubed minus x squared plus x from 1 to 2. So now let's just substitute the upper limit first. So substitute the upper limit 2 for every x. So we have 2 cubed minus substitute 2. So we have 2 squared plus 2 and then subtract to f of 1. So we have substitute 1. So we have 1 cubed minus 1 square plus 1. So simplify. So we have 2 cubed, that is equal to 8 minus 2 squared, so that is 4, and then plus 2, and then minus 1 cubed is still 1, minus 1, so we can cancel this. So what's left is the positive 1. So just simplify. So 8 minus 4, that is 4 plus 2, we have 6, and then minus 1, final answer is 5. Okay, so next number, number 2. Integral of 3x squared plus 4 over x squared dx. So again, we have direct formula for the two integrands. So just distribute the dx. So we have 3 here. So move the constant outside. So we have 3x squared. Distribute the dx from 1 to 3. And then from this, so move the 4 outside. And then we have over x squared. So make the denominator, make the exponent negative by putting this in the numerator. So this will become x to the negative 2 dx. So we can use the integral of u to the n du. Okay, so therefore we have direct formula. So we have x squared. So just add 1. So we have 3x cubed over 3 plus 4. So we have x raised to negative 2 plus 1. So that is negative 1 over negative 1. Oh, we forgot the limits here. So 1 to 3. So from 1 to 3. So let us just simplify. So we have cancel out 3 and then simplify this. So we have x cubed, positive 4, and then negative 1. So we have negative 4 and then put the exponent, make this positive by putting this in the denominator. So we have 4 over x from 1 to 3. Okay, so now substitute the limits. So we have substitute 3. So we have 3 cubed minus 4 over 3. And then substitute the 1 for every x. So we have 1 cubed minus 4 times 1. So simplify. So we have 3 cubed, that is equal to 27 minus 4 over 3. And then minus 1 cubed is still 1. And then this is minus 4. Okay, so let's simplify. So let's remove the parentheses or the symbol of grouping, the bracket. 27 minus 4 over 3. So this will become positive. This will become negative 1 and positive 4. Okay, negative 1 and then positive 4. So combine all the whole numbers. 27 minus 1, that is 26, plus 4, that is equal to 30, minus 4 over 3. So our answer must be in it can be whole mixed number or improper. So it's better if it is mixed number. So change 30 to 4 minus 4 over 3. So 4 over 3 is 1 and 1/3. So 30 minus 1 and 1/3. So change 30 to 29 and 3 over 3. Okay, so minus 1 and 1/3. So therefore, the final answer is 29 minus 1, that is equal to 28. 3 over 3/3 minus 1/3 is equal to 2/3. So the answer is 28 and 2/3. Okay, so next number, or you can solve this using the butterfly. So just cross multiply 30 times 3, that is equal to 90. 1 minus 4, so minus 4 over 3. Another answer in improper fraction. So we have 90 minus 4, that is equal to 86 over 3. So that's the same, 28 and 2/3 or 86 over 3. Okay, so next number 3. Integral of x times cube root of 1 plus x squared dx from 0 to square root of 7. So for this, if we let u as 1 plus x squared, the derivative of the differential of 1 plus x squared, so we have u is equal to 1 plus x squared. Our du will be equal to derivative of 1 is 0. The differential of x squared, so that is equal to 2x dx, which is this term, x and then dx. So we're just going to have a neutralizing factor because we have 2 here. So we can multiply both sides. We can multiply this by 2 and then by 1/2 outside the integral so that it is in the form u to the n du. Okay, so we have now 1/2 integral from 0 to square root of 7. So we have 1 plus x squared. So this can be written as 1 plus x squared. So cube root. So that's the same to raised to 1/3. And then we have x dx. So we multiply 2. So we have times 2x dx. So it is now in the form. It's now in the form. So this is our u. This is our n. And then we have u to the integral of u to the n du. Okay. So the direct formula is u to the n plus 1 over n plus 1. So that's why we multiply 2 and 1/2 to make it in the form u to the n du. Okay, so that is the neutralizing factor, the 1/2. Okay, so since it's in the form u to the n du, so we have direct formula, so that's equal to 1/2. We have apply this, so we have 1 plus x squared 1/3 plus 1. So that is equal to 4 over 3 over 4 over 3. From 0 to square root of 7. So simplify. So we have 1/2 and then 4 over 3. So 3 will go to the numerator. So this will become 3/4 times 1 plus x squared raised to 4 over 3 from 0 to square root of 7. So now let's just apply the limit. So substitute square root of 7 and 0. Okay, so we have 3/4 times 1 plus x squared. So we have square root of 7 and then square raised to 4 over 3. Okay, so minus 3/4 minus 3/4, substitute the 0. So we have 1 plus 0 square. 0 square raised to 4/3. Okay, so and then just simplify. So we have 1/2 times 3/4. So we have square root of 7 square. So we can cancel this. So we have 1 plus 7. So that will be equal to 8 and then 4/3. So raised to 4/3 minus 3/4. And then 1 plus 0. So we have, that's still 1 raised to 4/3. Okay? So we can simplify it. Simplify this 8 raised to 4/3. So we can take the cube root first. 8 cube root of first. Cube root of 8. So the cube root of 8 is equal to, cube root of 8 is equal to 2. Since 8 can be written as 2 cube. Okay, so let's replace this. Let's replace 8 by 2 cube. So we can cancel the numerator and then the denominator 3. So that is now equal to 2 to the 4th. Okay, so 2 to the 4th, that is equal to 16. Okay, so then if we simplify, so this will become 16 and then divide that by 4. 16 divided by 4, that is 4, and then times 3, that will be equal to 12. Okay? So we change 8 to 2 cube and then we cancel, and then 2 to the 4th, that is 2 times 2 times 2 times 2, that is 16. We divide by 4, that is 4, and then we multiply by 3. 4 times 3, that is 12. Okay, and then minus 1 raised to any exponent, that is equal to 1. So we have 12 minus 3/4. 12 minus 3/4. Okay, so simplify this. We can use the butterfly. So we can use the butterfly or over 1. So this will be equal to 1/2 times, just cross multiply. So 12 times 4, that is equal to, 12 times 4 is 48, minus 1 times 3, we have 3, over 1 times 4, that is equal to 4. So simplify, we have 1/2 times 48 minus 3, that is equal to 45 over 4. So the final answer is 45 over 8. Or if you want to change in mixed number, this is the same to 45 divided by 8. So that is 5, 40. 8 times 5 is 40. So we have 5. And then the remainder is, so that is 5 and 5 over 8. So another answer. Okay, so next number, number 4. Number 4, we have integral of x dx over x squared plus e from 0 to e. E here is constant, the constant e, to approximately 2.71828 and so on. So what do we have a direct formula for this? Yes, we will use the integral of du over u. Because if we let u as x squared, plus e, the differential of that is equal to derivative of x squared, that is 2x. Okay, and then this is constant. So derivative of e is 0. So just multiply to the x. So we have 2x dx. In the numerator, we only have x dx. So we can multiply this by 1/2 and then 2x dx over x squared plus e from 0 to e, so that it is now in the form integral of du over u, which the answer is ln u plus c. Okay, so therefore the answer will be 1/2 and then it's in the form du over u. So therefore the integral is ln of the denominator x squared plus e from 0 to e. So now we substitute the limit. So we have 1/2 and substitute the limit. So we have ln of x squared, or sorry, this will be ln of e squared plus e, and then minus ln of x squared. Oh, sorry, x should be substituted to 0. So 0 squared plus e. Okay, so then simplify. So we have 1/2 ln of, so there's no, way to add this, e squared plus e. We can factor out e. So that can be, if we factor out e, so we have e times e plus 1. Okay? And then minus ln of 0 squared, that is 0. So we have minus ln e. Then we can apply the property for this. Okay, so ln e is equal to, so this is a property, ln e is equal to 1. Okay, so therefore, and then for the first one, we have product, the ln e times e plus 1. So we can use the property. If we have a product ln ab, that is equal to ln a plus ln of b. So if we have plus, we can combine this and then multiply the a and b. So if we simplify this, so this will be equal to 1/2. And then we have ln of the product e, and then the second factor is e plus 1. So we have ln e plus ln e plus 1 minus ln e. Okay, so ln e, that is 1. But we have ln e here and then minus ln e. So we can simply cancel this. So therefore, the final answer is 1/2 ln of e plus 1. So approximately, if you want to evaluate this, if you use your calculator, the approximate answer for this is, we have 1/2 ln of e plus 1. So the value of ln e plus 1 in your calculator, that is equal to approximately 1.31. 1.31326, and then we have 1/2 here, so divided by 2. So the approximate answer is 2 decimal places, gawin natin 0.6566. So the exact answer is 1/2 ln e plus 1. So this is the approximately equal to 0.6566. Okay, so next number, number 5. Last number, number 5. So we have integral of sine squared x cosine x dx from 0 to pi over 2. Okay, so it is in the form, if we let u as sine x, our du will be cosine x dx. So it is in the form u integral of u to the n du. So this will be our u, the sine x. The n will be 2, and then this is the du. Okay, so therefore, we have direct formula. So direct formula for that is the integral is equal to sine, just add 1 to the exponent, sine cube x over x, or sorry, sine cube x over 3 from 0 to pi over 2. 0 to pi over 2. So now, let's just substitute the limit. So apply the limit. So we have sine pi over 2, that's the same to equal to 90 degrees. Okay? So pi over 2, that is equal to 90 degrees. So sine cube of 90 degrees over 3 minus sine of 0 or 0 degrees, 0 radian, still 0 degrees over 3. Okay, so what is now the value? So let's recall the unit circle. So this is the unit circle. So this is the 90 degrees and this is the 0 degrees. So the coordinates of this in the unit circle, so this is 1, 0, and this part is 0, 0, 1. So this is the value of cosine, and then this is the sine. Okay? So therefore, so this is the sine 90 degrees is 1. Because from the unit circle, the x is the cosine and y is the sine. So therefore, sine 90 degrees or sine pi over 2. So pi over 2, pi is 180. So 180 divided by 2, that's the same to 90 degrees. So therefore, our answer will be sine 90 is 1. 1 cube is still 1 over 3 minus sine 0. So sine 0, so this is the value of cosine. Sine 0 is 0. So we have 0 over 3. Final answer is 1/3. Okay, so that's all. So I hope you learned something from this video. Thank you for watching and see you on my next tutorial on integral calculus, area under a curve. So again, thank you for watching. Bye-bye and God bless.